Hello students, I am Subhashish. In our everyday world, shapes and measurements are all around us. Think about the floors you walk on, the tiles that cover them, and even the triangles that make up those tiles. Have you ever wondered how we find the area of a triangle like the ones on those tiles? Well, in school we learn cool methods to do just that. Imagine you have 3 points on a plane and they make a triangle. We can figure out how big the triangle is using special math formulas. Let's dive into how we can calculate the area of a triangle using the coordinates of its corners and see how this math can help us understand spaces in our daily lives. Learning outcomes. At the end of this lesson, you will be able to calculate triangle area using vertices and distance formulas. Determine collinearity through zero area and equation conditions. Apply Heron's formula and coordinate methods for triangle area calculations. Keywords from this lesson are triangle, area, vertices, coordinates, collinearity, Heron's formula. In your earlier classes, you studied how to calculate the area of a triangle when its base and corresponding height are given. You have used the formula area of triangle is equal to half into base into altitude square units. With any 3 non-collinear points, A x1, y1, B x2, y2 and C x3, y3 on a plane, we can form a triangle ABC. Using the distance between 2 points formula, we can calculate AB is equal to C, BC is equal to A and CA is equal to B. Where A, B, C represents the length of the sides of the triangle ABC. Using 2S is equal to A plus B plus C, we can calculate the area of triangle ABC by using Heron's formula root over S into S minus A, S minus B into S minus C. But this procedure of finding the length of sides of triangle ABC and then calculating its area will be a tedious procedure. There is an elegant way of finding the area of a triangle using the coordinates of its vertices. We shall discuss such a method below. Let ABC be any triangle whose vertices are at A x1, y1, B x2, y2 and C x3, y3. Draw AP, BQ and C are perpendicular from A, B and C to the x-axis respectively. Clearly, ABQP, APRC and BQRC are all trapeziums. Now, from the above figure, it is clear that area of triangle ABC is equal to area of trapezium ABQP plus area of trapezium APRC minus area of trapezium BQRC. You also know that the area of trapezium is equal to half into sum of parallel sides into perpendicular distance between the parallel sides. Therefore, the area of triangle ABC is equal to half into BQ plus AP into QP plus half into AP plus CR into PR minus half into BQ plus CR into QR. That is equal to half into y2 plus y1 into x1 minus x2 plus half into y1 plus y3 into x3 minus x1 minus half into y2 plus y3 into x3 minus x2. By simplifying, we get half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Thus, the area of triangle ABC is the absolute value of the expression, that is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square units. The vertices A x1 comma y1, B x2 comma y2 and C x3 comma y3 of triangle ABC are said to be taken in order. If A, B and C are taken in a counterclockwise direction, if we do this, then the area of triangle ABC will never be negative. We will see another form. The following pictorial representation helps us to write the above formula very easily. Area of triangle ABC is equal to half into x1 into y2 plus x2 into y3 plus x3 into y1 minus x2 into y1 plus x3 into y2 plus x1 into y3 square units. Let us see one example. Find the area of the triangle whose vertices are minus 3 comma 5, 5 comma 6 and 5 comma minus 2. Solution. Plot the points in a rough diagram and take them in counterclockwise order. Let vertices be A minus 3 comma 5, B 5 comma minus 2 and C 5 comma 6. Area of triangle ABC is equal to half into x1 into y2 plus x2 into y3 plus x3 into y1 minus x2 into y1 plus x3 into y2 plus x1 into y3. Now substitute all the values in the formula, then we get half into 6 plus 30 plus 25 minus 25 minus 10 minus 18. By solving, we get half into 61 plus 3. By adding them, we get half into 64. Then by simplifying, we get 32 square units. Let us see one more example. Show that the points P minus 1.5 comma 3, Q 6 comma minus 2 and R minus 3 comma 4 are collinear. Solution. The points are P minus 1.5 comma 3, Q 6 comma minus 2 and R minus 3 comma 4. Area of triangle PQR is equal to half into x1 into y2 plus x2 into y3 plus x3 into y1 minus x2 into y1 plus x3 into y2 plus x1 into y3. Now substitute all the values in the formula. We get half into 3 plus 24 minus 9 minus 18 plus 6 minus 6. By solving, we get half into 18 minus 18. That is equal to 0. Therefore, the given points are collinear. Let us see another example. If the area of the triangle formed by the vertices A minus 1 comma 2, B k comma minus 2 and C 7 comma 4 taken in order is 22 square units. Find the value of k. Solution. The vertices are A minus 1 comma 2, B k comma minus 2 and C 7 comma 4. The area of triangle ABC is 22 square units and also equal to half into x1 into y2 plus x2 into y3 plus x3 into y1 minus x2 into y1 plus x3 into y2 plus x1 into y3, that is equal to 22 square units. By substituting all the values in the formula, we get half into 2 plus 4k plus 14 minus 2k minus 14 minus 4 is equal to 22. By simplifying, we get 2k plus 34 is equal to 44. That gives 2k is equal to 10, so k is equal to 5. Let us see one more example. The floor of a hall is covered with identical tiles which are in the shape of triangles. One such triangle has vertices at minus 3, 2, minus 1, minus 1 and 1, 2. If the floor of the hall is completely covered by 110 tiles, find the area of the floor. Solution: vertices of one triangular tile are at minus 3, 2, minus 1, minus 1 and 1, 2. Area of triangle ABC is equal to half into x1 into y2 plus x2 into y3 plus x3 into y1 minus x2 into y1 plus x3 into y2 plus x1 into y3. By substituting all the values in the formula, we get area of this tile is equal to half into 3 minus 2 plus 2 minus of minus 2 minus 1 minus 6 square units. By simplifying, we get half into 12. That is equal to 6 square units. Since the floor is covered by 110 triangle shaped identical tiles, therefore area of floor is equal to 110 into 6, that is equal to 660 square units. Summary of the lesson. The area of a triangle determined by coordinates is obtained by calculating the absolute value of a specific expression. When points are collinear, the area of triangle they form is always 0. For triangular tiles, the area is half the product of the tile's base and height. Heron's formula: area is equal to under root s into s minus a into s minus b into s minus c. Thanks for watching.